How long will it take this port to transition to the forwarding state if we plug a cable into it? Well, notice we have our PC connected to it, but what if it was a phone or a printer? It will take 30 seconds. Now, why 30 seconds? The forward delay timer, which is 15 seconds, that is utilized in the listening and learning states, are going to cause it to be a total of 30 seconds. Let's examine that. PC1 is connected to Fast Ethernet 0/1. Let's go to interface Fast Ethernet 0/1 and shut it down. We will turn on a debug, do debug spanning tree events. And now let's re-enable this interface. Let's analyze the process that the interface is going to go through. Look, listening. Fast Ethernet 0/1 is in the listening state. We'll spend 15 seconds in that listening state. And then we'll transition to the learning state. And once we are in the learning state, we're going to spend another 15 seconds in the learning state. As you can see, 15 seconds is a really long time, especially when somebody like myself just keeps talking and boring you. All right? So once we're done this learning state in 15 seconds, we go to the forwarding state. But another issue is that we send a topology change notification about the fact that this interface came up. This interface going to the forwarding state, does it change the spanning tree topology? No, it does not. So this is an insignificant topology change notification that is being sent because it doesn't affect any other switch in the network. It's a waste of resources. So how can we ensure that the interface that we're dealing with here transitions to the forwarding state really, really fast, and it does not generate a topology change notification? We enable PortFast. That's what we do. So PortFast is another feature that improves the overall convergence time or transition time for an interface to go to the forwarding state. So PortFast can be enabled on a global basis or on an interface basis. If we go to global configuration mode and type in spanning tree PortFast default, it enables spanning tree protocol on every single interface that's an access port. So whatever you have switch port mode access configured on, spanning tree PortFast will be enabled on those interfaces. With spanning tree PortFast in interface configuration level, you will configure PortFast or enable it on that interface regardless of the type of port it actually is. So you want to be very careful with this. And it even warns you when you're configuring it. So if we type in spanning tree PortFast for Fast Ethernet 0/1, to enable it, it tells you PortFast should only be enabled on ports connecting to a single host. Connecting it to hubs, concentrators, switches, bridges, etc., blah, 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 can cause a temporary bridging loop. And you don't want loops at all in your topology, so be very, very careful with this and make sure you're enabling it on the correct interfaces within the topology. If we look at the output now of do show spanning tree for VLAN 10, you'll see here that Fast Ethernet 0/1 is now considered an edge port. It's a PortFast enabled port. So if we bring down that port, let's shut it down, and then we will re-enable it. Let's see how quickly it moves to the forwarding state. Do we have to wait 30 seconds this time? And the answer to that question is no. We immediately jump to the forwarding state from the blocking state, and notice how there is no topology change notification that is sent about this state change. So we are improving resource utilization as well as moving to the forwarding state rapidly. Now, if we examine a little further this PortFast configuration, we can use the command show spanning tree interface Fast Ethernet 0/1 detail. And when we add on the detail keyword, we can look specifically at this interface and see that this port is in the PortFast mode. So this is a way to verify that this port is in the PortFast mode. But we also saw here with the output of show spanning tree for VLAN 10 that it's an edge port, meaning it is enabled for PortFast. You'll also see this option here, show spanning tree interface fast Ethernet 0/1 PortFast. It says we are enabled for PortFast on VLAN 10. Well, I received the same information by looking at this output, and I also saw the same information by looking at the output of show spanning tree interface fast Ethernet 0/1 detail. So I get all that information there anyways. However, we did mention that you could enable PortFast globally. So let's do so. That way their fast Ethernet 0/2 is also enabled for PortFast. Type in configure terminal, and the command is spanning tree PortFast default. So this says enable PortFast on all of the access ports automatically. So if we ever add any more access ports, then they will automatically become PortFast enabled ports. So now if we look at the output of do show span for VLAN 10, you can see that fast Ethernet 0/2 is an edge port. Also, if you examine the output of show spanning tree interface fast Ethernet 0/2 detail now, you can see that the output says the port is in the PortFast mode by default. So whenever you see by default, you know it was enabled globally for this particular interface, where if by default is not listed, the command spanning tree PortFast was enabled on that interface. So that's the difference between 0/1 and 0/2 in this case. When you're looking at this output, you will understand how PortFast was enabled by that particular output. On top of that, if you look at the output of show spanning tree summary totals, you can get a bird's eye view. Reestablish my connection here. All right, so if we look at the output of show spanning tree summary totals, we can see from this output here a bird's eye view of those features that are enabled for spanning tree protocol. And here it says PortFast default has been enabled with that global configuration command of spanning tree PortFast default.